Hello students, so in our chapter, that is system of particles and rotational motion, I have already explained in my earlier videos, that is rigid body, motion of rigid body, then center of mass, motion of center of mass, then moment of inertia of some regular shaped bodies, then some applications of moment of that is two theorems and their applications. So today I will explain two important topics, that is one is torque, another is angular momentum. Okay, so these are very important because without torque rotational motion is not possible. For example, force is responsible for what? Translational motion. Unless we apply some force on a body, the body will not change its state, changes your position of rest or uniform motions. Similar way, unless we apply some torque, a body cannot change its rotational inertia. Okay, so let me first explain what is torque. Now whatever the concept you have in your mind about force, same concept, okay, same concept of torque, just it is in rotational motions. Okay, so you see, this is suppose a body. If we apply the force at the center here, the body moves straight line, linearly. If we apply the force in the line of center of mass, the body moves straight. That is force. But if we apply the force just away from center of mass here, suppose you are applying the force here, then it will turn the body, means it rotates the body. So that effect of force is called what? Torque. The torque is nothing but the effect of force, the moment of force. Okay, the rotational effect of force, the turning effect of force, that is called what? Torque. So whatever the force that turns the body, rotates the body about some axis, that turning effect of force is called what? Torque. So torque means what? It is the, you can say, the moment of force. The moment of force or the turning effect of force. The turning effect of force is called torque. Okay, is called torque. So you can represent it by tau. Okay, just you visualize whatever the force you apply, if it turns the body, rotates the body, that effect is called what? Force. Okay, torque. Now let me define it mathematically. Okay, mathematically I have been defined. So let us consider a coordinate system here. Now suppose this is a particle here, this is a particle, okay, and you apply force. Suppose you apply force here. This is a line of action of force I am applying here. This is the force I am applying on this body. Okay, this is the position vector of the body. This is the position vector of the body. R is position vector. Okay, this is suppose xy. The angle between force and position vector, suppose theta. Now you draw a perpendicular on the line of action of force from the position vector. So this is a perpendicular here. So this is r, this angle is theta. So this is r, suppose perpendicular. Now mathematically, force is defined as the torque is defined as the product of force and the perpendicular distance. So perpendicular between what? Between the line of force, line of action of force, okay, from the origin. Okay, so here torque is defined as the product of force into perpendicular distance. Okay, so it is F into R perpendicular. Now what is R perpendicular here? It is nothing but, we find out this value, this angle theta, so this is perpendicular, so it is here, it is R sin theta. So torque is what? It is RF sin theta. So this is the formula of torque. In vector form, it will be what? R cross F. R cross F. Okay, it is R cross F. So this is the torque. So here, what is R perpendicular here? It is the perpendicular distance between the line of action of force from the origin of coordinates of coordinate axis. Okay, So this is R into F. So here you know this is the cross product of R and F. What is the direction of this torque? So from here you can say, since it is equal to R cross F, so torque is what? It will be perpendicular to the plane containing R and F. Okay, so that you can find out from right hand screw rule. Okay, that is torque is perpendicular to the plane containing R and F. For example, you see, suppose this is R, suppose, and this is suppose F. Okay, then if we going from R to F, then this is the direction of what? Torque. So torque, this is perpendicular to what? The plane containing R and F. So R and F lying in this plane here. This suppose R, this suppose F. So this is direction of torque. So torque is what? Normal to the plane containing R and F. Okay. So this is about torque. So you have to remember this formula in vector form, and this is magnitude RF sin theta. F is the magnitude of force and R is the perpendicular distance. And what is the physical concept of torque? Is simply the turning effect of force is called torque. The rotational effect of force is called torque. The moment of force is called torque. You can say the force which turn the body. That effect is called what? Torque. Okay. Now, same way, same concept, that is for angular momentum. Okay. Angular momentum. Angular momentum. So just like force and torque, they are related. Force for translational motion, torque for rotational motion. Exactly similarly, you know, linear momentum and angular momentum. So whatever the role of linear momentum in translational motion, same role played by angular momentum in rotational motion. Just I have explained that moment of force is called torque. So moment of linear momentum is called what? Angular momentum. Turning effect of force is called torque. Turning effect of linear momentum is called angular momentum. So linear momentum we use in translational motion and angular momentum we use in rotational motion. So here you can say the moment of linear momentum is called angular momentum. Angular momentum. Okay. So how can you define mathematically? It is denoted by what? L. So it is defined as what? Same. That is linear momentum into what? Perpendicular distance. Like torque, force into perpendicular distance, angular momentum, linear momentum into perpendicular distance. So if this is direction of force, then this will direction of linear momentum, because force and momentum they act in same directions. So this is the perpendicular distance. Okay. So here it is linear momentum into perpendicular distance. So what is perpendicular distance? It is R sin theta, as I have shown earlier. So it is RP sin theta. So this is L. So in vector form it is what? L is equal to what? It is R cross P. So exactly same concept. Here also you can say that L is what? L is perpendicular to the plane containing R and P. Okay. So if this is your suppose R and this is direction suppose P, they are lying in the plane, this angle is theta, then this will be what? Direction of angular momentum. So angular momentum is perpendicular to the plane containing R and P. So this is L, this will be R cross P. Okay. I think you understood the concept of torque and angular momentum. Okay. So whatever the concept of linear momentum in translational motion, just same concept of angular momentum in rotational motion. Now, here I will compare between translational motion and rotational motion, so that you need not to derive the equations of rotational motions. You can just comparing with translational motion, you can remember or you can find the relation for rotational motion. Then it will be more simple for you. Okay. So let me compare comparison between translational and rotational motion. Okay. Rotational motion. Translational motion. Rotational motion. First, here we have mass. So here we use what? Moment of inertia. Moment of inertia, I. And what is the relation between them? Already I have given you. I is equal to what? mr square, or summation of mr square. Depending on the body it will be different. Okay. Then you have, say, displacement. Displacement, say it is S. Here you have angular displacement. Angular displacement, that is theta. And what is the relation between them? That already you got in chapter, the third chapter, that is vector and projectile. Okay, motion in plane. What is the relation? S is equal to R into theta. Okay, R is radius, theta is angular displacement. Then you have velocity. Velocity, that is V, and V you know, ds by dt. Here you have angular velocity. Angular velocity, okay? Velocity, omega. And you know, omega is what? It is d theta by dt. And the relation between angular velocity and linear velocity, you know, V is equal to R omega. Okay. So we have to follow the formula as well. Then acceleration. Acceleration. You know, A is equal to what? dv by dt. Here angular acceleration. Okay. Angular acceleration. It is alpha. Okay. So alpha is what? d omega by dt. It is alpha equal to, relation is what? A is equal to R into alpha. So that these relations already you learned in chapter motion in plane. Okay. I am just comparing the two motions. Then you have momentum. That is linear momentum. Linear momentum. P. P is equal to what? M into V. So here it is angular momentum. Angular momentum, L. So L will be what? Just to compare, here you see P is equal to M into V. For mass, what we write? For mass, we write moment of inertia. And for velocity, what we write? We write angular velocity omega. So you see, just you can derive the formula, you can write the formula just by comparing. Here P is equal to mv. So here L will be what? For M, we write moment of inertia. For velocity, we write angular velocity. Okay. And the relation between these two is what? Already I have given you. L equal to what? R cross P. Just I have derived. Okay. Then you have torque. Then we have force. The force you know F equal to ma. So here we have torque. Torque will be what? So now you just compare. You see F equal to ma. For mass, what we write? Moment of inertia. For acceleration, what we write? Angular acceleration, alpha. The formula is what? Torque equal to I alpha. And the relation between these two is what? Torque equal to R cross F. So you see, these are the main 6 quantities. Okay, that whatever we use in translational motion, just analog in rotational motion. You see mass, moment of inertia. Displacement, angular displacement. Velocity, angular velocity. Acceleration, angular acceleration. Linear momentum, angular momentum. Force, torque. Now, if we remember these conversions, okay, translation to rotation, then any formula that we use for translational motion, you can write it for rotational motion just by replacing the symbols. If there is mass, you replace by moment of inertia. If there is displacement, replace by angular displacement. For velocity, you apply angular velocity. For acceleration, use angular acceleration. For linear momentum, use angular momentum. For force, use torque. Okay, let me show you. Okay, how can you convert the formulas for in translational motion for rotational motion. Okay, let me show you. For example, you see, you know F equal to what? Newton's second law, dP by dt. That is force equal to rate of change of what? Linear momentum. If we write this formula for rotational motion, what we use? In place of force, we write torque is equal to dP by dt. In place of momentum P, what we write? Angular momentum, dl by dt. So just by changing a symbol, you can use the formula. Okay. Any other formulas you can see. You see kinetic energy of translational motion. What is that? You know, half m v square. So for rotational motion, what we use here? Kinetic energy for rotational motion, it will be half. In place of mass, we write moment of inertia. In place of velocity, I write angular velocity. That is half I omega square. So just by changing symbols, you can write the formulas. Okay. Any formulas. Okay. You see power. Power, you know, work done by time or force into velocity. So here, how can you write this formula? Power in rotational motion, work done by time, that remains same. Here, force into velocity. So torque into angular velocity. So here you change the symbol. Okay. Suppose you have any formula you can use for rotational motion. That is, you know, relation between kinetic energy and linear momentum. You know, kinetic energy translational motion is what? P square by 2m. And momentum is what? Root over 2mk. That we know already. Okay. So here in rotational motion, I can write it. Kinetic energy of rotational motion, it is L square by 2I. Just change the symbol. Then angular momentum will be what? Root over 2ik. Okay, for translational motion. So just by changing the symbol, you can use the formula for rotational motion. Okay. Now suppose equations of this is for kinetic equations. That is, you can use, you know, V is equal to U plus AT. Here, what will be the equation? In place of V, it is angular velocity omega, initial velocity, initial angular velocity, A means alpha into T. So just you can changing the symbols. Okay, you know V square equal to what? U square plus 2AS. So here it is omega square equal to what? Omega square plus 2 alpha theta. Okay, then you have S is equal to UT plus half AT square. Now here how can you write it? Theta is equal to what? Omega naught T plus half alpha T square. So just you see any formulas that we use in translational motion, we can write it for rotational motion just by changing the symbols. Okay. So need not to worry. So if we forget the formula for rotational motion, you just try to remember the relation for translational motion. By borrowing that formula, you just change the symbol you can use for rotational motion. Okay. Law of conservation of angular momentum. Angular momentum. So just like law of conservation linear momentum, what you have learned in laws of motion chapter, same, exactly same concept. Now we know, already I have explained, that is torque is equal to what? dl by dt. If you forgot, you just write equation for force. Okay, F equal to what? dp by dt. You see, just I am changing the symbols. In place of force, I am writing torque. In place of linear momentum, I am writing angular momentum. So torque equal to what? dl by dt. Now if torque equal to 0, then dl by dt is equal to 0, or dl equal to 0, or L equal to what? Constant. So this is called law of conservation of what? Angular momentum. Now here L is what? I omega equal to constant. Because L you know, P is equal to mv. So L is equal to what? I omega. Or you can write I1 omega 1 is equal to I2 omega 2. So this is one of the important relations. Okay. From this part, you will get questions in your NEET as well as in JEE Mains. Okay. From this is very important, law of conservation of angular momentum. So what is that? You can say that if no external torque is acting on the body or system, then the angular momentum always remains constant. Always remains constant. Okay. So this is called law of conservation of angular momentum. If no external torque is applied, then your angular momentum always remain constant. So this is your law of conservation of angular momentum.